Hello friends, this is Satish Nikam from MEP's KBT College of Engineering, Nasik. Now in this lecture, we are going to discuss about the memory organization of internal RAM for 8051 microcontroller. What is the function of RAM? It is very simple, to store the data temporarily. To store the data temporarily means what? When we read the data from a particular port, suppose port 0, port 1, port 2, port 3, these are my 4 ports which I am having in 8051 microcontroller, which can be used as an input port and output port. But suppose we got the data from a particular port and you have to store it somewhere. So where I am going to store it? So RAM is the best option. RAM is the first option, we can say. Correct. So RAM is the memory where we can store the data temporarily. Suppose you have to perform the addition of two temperatures that I am going to read from port 0 and port 1. So first I have to read that data. I am going to put it on some memory locations of the RAM. Then I have to calculate the average of it. So what I will do? I will take the first data from that memory location. I will take the second data which is already present on the second memory location. I will perform the addition and then I am going to divide it by 2. Whatever may be the result I got, again I am going to store it on RAM. So this type of processing, when it is get carried, RAM plays a very important role. What will be the total size of my internal RAM in case of 8051 microcontroller?
128 bytes.
Very good, very correct. 128 byte. Correct. So here we are going to discuss about the RAM. Now my total RAM is 128 byte, as I told you in case of the programming model. This 7F, this is a hex number. Memory locations are denoted in a hex form. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F, 1, 0, 1, 1. This is my hex number system. And in this hex number system, the last memory location is denoted by 7F. If you convert this 7F into decimal, you will get 127. So total 0 to 127 means total 128 memory locations are there. And this total 128 memory locations, it is get divided into 3 sections first. What is the first section? That is working registers, or also we can call them as a bank area. Working registers, or we also called it as a bank area. Second section is my bit addressable area. I am going to discuss these sections in detail. Okay, but first I am going to divide it into 3 parts. First, bank area, second, bit addressable area, and third is a general purpose area. General purpose, okay, you can use it for as per your requirement. So we called it as a general purpose area. But these two are very important. So first one, as I told you, this is a working register area, or we can say the bank area is a very important thing. When you got the data from a particular port, then that information may be, see, when you are going to read the information from the external peripherals or the external environment, that information may be in the 2 types. First one, either the 8-bit data, means when I convert my temperature into analog form, and that 0 to 5 volt, it is get converted in digital form by using my ADC. Output of the ADC is my 8-bit data, and that 8-bit data is actually going to represent the temperature which I have sensed through the thermocouple. Yes. Now I have to store that data, 8-bit data, on a memory location. I can use this bank area. Check here. I can use this bank area. Now again, R0 to R7 is the first bank. This bank area again get divided into 4 banks. So bank 0, bank 1, bank 2, bank 3. These are the 4 banks, and in every bank we are having R0 to R7, R0 to R7, R0 to R7, R0 to R7. Every bank contains 8 registers, and every memory location is having address. Remember, as I told you in the programming model, every register is having address. Only one register which is not having address, and which is a program counter register. Remember. So here every memory location, actually what is RAM? RAM is a combination of registers, simple. RAM is actually the combination of registers. So these 8 registers are there having memory location 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 up to 1F, 00 to 07, 08 to 0F, 10 to 17, 18 to 1F. These are the memory locations for my bank 0, bank 1, bank 2, bank 3, and you have to draw this. So what is the use of this? when you have to store, you got the data from the port, and that data, it is of 8 bit, you have to store that data on a memory location temporarily. So you can use this area, and this area we called as a bank area, or we also called it as a working registers. Next is my bit addressable area. Now, as I told you, there are two types of information. The first example which I have already given, when I have to measure the temperature, that temperature is in a, first we convert measure by thermocouple. So, what is the output of a thermocouple?
Millivolts.
It is in millivolts. Very good, very correct. That millivolts, by using signal conditioning circuit, we are going to convert it into 0 to 5 volt. That 0 to 5 volt, by using ADC, we are going to convert in a digital form, and that digital form of 8 bit data we are getting from a port, and that we are going to store on the bank area. This is one type of information that we are getting from the external environment. But another type of information is there. Suppose I am having one wall. That wall is open or closed. That wall is of only two states. Either it is closed or it is open. That I have to check. So, what type of information you will get? Whether it is a 8 bit information? Very good, very good, very good. The information, it is in a single bit form. If that bit is, it is a single bit form. If the bottle is present, we will get 1. If the bottle is not present, we will get 0. So, that type of digital information also we got from the external environment, and that we have to store. So, if I am going to store I can store that information in these registers, but I am going to waste total 8 bits. So, there is a particular area in which we can store the single bits, and that particular area we call bit addressable area. Why we call this as a bit addressable area? Because every cell is having its address. That part we will discuss in the next slide, but this is a figure from a book of Kenneth Ayala. This is byte addresses. As I told you, this is get started from 00 to last memory location. It is my 7F. ये change करना पड़ेगा इसको. This should be 7F. Last memory location for the general purpose area, it is 7F. But we will discuss the general purpose area afterward. But here remember 0 to 07. Total 8 memory locations are from the bank 0, 08 to 0F bank 1, 10 to 17 bank 2, and 18 to 1F is my bank 3. And from 20 to 2F total we are having 16 memory location, and that 16 memory locations we call bit addressable area. Now here in every memory location, now if we check the memory location 20, on this memory location definitely we are having 8 bits, and these 8 bits are also having their own address. They are also having their own address, means this particular cell is having address 00. Next cell is having address 01. This is 02, 03, 04, 05, 06, 07. Next memory location 21 LSB bit, it is 089A. B, C, D, E, F, 10, 11, 12, 13, 14, 15, 16, 17. This way we are having address for every cell from the bit addressable area. Total 16 memory locations are there, and on one memory location we are having 8 bits. So, how many total number of bits are there?
128.
Very good, very correct.
16 into 8.
Correct, 16 into 8, very good. But the answer is exactly it is 128 bits. My total RAM is also 128 bytes, and my total number of bits are also 128. See, this is bit addressable area. As I told you, memory location 20 to 2F. Memory locations are 00, 01, 02, 03, 04, 05, 06, 07, 8, 9, A, B, C, D, E, and F. 10. Like this, if you draw the memory locations, cell locations we can say, not memory locations. These are the memory locations. 20 to 2F are the memory locations, and cell addresses are here. The last address is my 7F. As we have discussed in case of the RAM also, the last memory location of my RAM is also 7F, 00 to 7F, and my bit addresses are also from 00 to 7F. Now, this particular cell, it is denoted by two ways. Either you denote it by the address 1A, or you can also denote it by the memory location 23. It is the bit from 23 memory location, and bit number LSB bit is 0, 1, 2, 3, 4, 5, 6, 7. In one memory location we are having total 8 bits, and the addresses are 0 to 7, 0 to 7, total 8 bits are there. Okay. So, what is the address of this particular cell? 23 memory location 0, 1 and 2. 23.2 is the address of this particular cell. This is one way how we represent the address of this particular cell. So, here 20 to 2F, total 16 locations are there. Into on one memory location we are having 8 bits. So, total 128 bits are there. And bit addressing, suppose I have to pick up the content from this particular cell, as this is having only one bit. What is the capacity of that cell? How much data you can store on that particular cell is a single bit. Either you can store 0 or you can store 1, because the information which I am getting, whether the bottle is present or not, that type of information which I am getting, it is of single bit, and that type of information I have stored on this particular cell. Now, I have to move the data from that cell to a carry flag. So, this is a simple instruction. Now, do not bother about the instruction, I am going to explain you here in short, but this instruction sets we will discuss in detail. Move, we are going to move the data from one particular position to another position. So, there is my source and destination. So, this is my source and this is my destination, correct. So, from this particular cell, what is the address of that cell? It is 1A. From the cell 1A, you are going to pick up the content and you are going to put it into a carry flag. This is the meaning of this particular instruction, first instruction. So, this way we can represent, as we know, the addresses of every cell. But another way of representation for the same cell, this is the cell from a memory location 23H. So, we are going to write down here 23H, and point, this is 0, 1, 2. So, this is the 2 that we are going to write down here. The cell number from the LSB side, it is 2. So, I write down here 2. So, 23H.2 is the address of again same cell. So, these two instructions are having same meaning. This is all about the memory organization of internal RAM. Now, in next lecture, we are going to discuss about the program status word, that is PSW register. Thank you.